The length of time, T months, that an athlete stays in an elite squad can be modelled by a normal distribution with population mean mu and population variance sigma squared is 15. So sigma, of course, would be the standard deviation. An independent sample of 5 values of T is given here. We want to calculate the mean of the sample and state the distribution that a large number of such samples is expected to follow. So we want the mean, so there's 5 values here. So just be careful with this because it's so easy to do this correctly, but also just miss one value or mistype one value and you're losing an easy mark. So 7.7, add 15.2, add 3.9, add 13.4, add 11.8. We're dividing that by 5. Always just check your values before you hit execute. And that's 52 over 5, which is of course 10.4. So the sample mean, so let's call it x bar, is 10.4. And so we can say that that's going to follow a normal distribution and the population mean would be the same. Now we're given the population variance here, and what we would do is divide that by 5 because there's 5 in the sample. Remember, when we've got standard deviation, it's sigma over root n, so it stands to reason that it's sigma squared over n. And so that's going to be a normal 10.4 and 3. Use the sample to construct a 90% confidence interval for mu, giving the bounds of the interval to 2 decimal places. There's 3 marks here, so we have to show some working. And remember that this 3 is the sigma squared over n. So root 3 will be equal to sigma over root n. We don't need to divide by 5 again at any stage. So if we go to inverse normal CDF, take a center setting with a probability of 0.9, we'll get the relevant Z value. So 1.645, so we're going to have 10.4 take away 1.645 multiplied by the standard deviation. And as we mentioned before, this one has already been adjusted for the number of things in the sample. And then we've got 10.4 add 1.645 times root 3. So all we need to do is calculate. So we've got 10.4 take away 1.645 multiplied by the square root of 3. That gives us 7.55. And then if we just go back and change that one to a plus, 13.25. And it's not a bad idea to check these things. So if we go to statistics here, calculation, and we want an interval, and it's a variable, and then 0.9, our sigma was the square root of 15. And that was 10.4. And we had 5 in each sample, and then if we go next we can see the 7.55 and the 13.25 here. Determine the smallest number of values of t that would be required in a sample for the total width of a 95% confidence interval for mu to be less than 3 months. So we're talking about the whole confidence interval being 3 months, and therefore half of it would be 1.5 months. It's a 95% interval we're after, so we need the relevant value of z. So we're going to go for the inverse normal this time, and we'll go center again, and the probability this time is 0.95, and so we're wanting 1.96. So our Z value is 1.96. So we'll need 1.96 times sigma over root n to be equal to 1.5. We could just solve this on the calculator. So let's just solve 1.96 times the square root of 15 over the square root of x equals 1.5. That will give me 25.6. So, and of course we'll have to go upwards, because at 25 the width would be slightly more than this, so n is 26.